Okay, so in our last class, we have solved till example 7.6 and we are going to start with 7.7. So 7.7 starts as the mean of binomial distribution is 3 and the variance is given as 4. So let's write it. Mean is 3 and variance is 4. Okay, solution. What you have to find is we have to derive or find the value of the parameters n and p and the formula for what are n and p. Okay, mean is n times p and variance is n times p times q. So both of these you can substitute. Dividing, we will get the value of q. So these two terms will cancel out and q will be 4 divided by 3, which is impossible since probability cannot exceed unity. So this will give you 1 point something something, and any one probability of an event cannot exceed 1. So that was just the comment. So example 7.8, the mean and the variance are also given in the same manner, that is 4 and 4 by 3. Find the probability of x greater than, okay, that be the event with an NP, then mean EX is equals to NP is equals to 4 and variance X is NPQ is equals to 4 by 3. See, in this question it was 3 and now it's 4 by 3. So if you will divide, you will get 4 upon 4 by 3, that is, sorry, 4 by 3 upon 4, so 1 by 3. So it's valid. So we'll solve the next step. Dividing, we'll get the value of q that I've already told you, 1 by 3, and p will be 1 minus q, that is 2 by 3. Okay. Now we have got the value of p and q. Substituting these values in the formula, the formula was this one. So n is equals to, transposing this, 4 by p, that is 4 by 2 by 3. This will cancel out and it will be 2 into 3, 6. So this is the value of n. That was, what was that? We have taken it here. Then now you can find the p and q. 1 minus p x equals to 0 is equals to 1 minus q to the power of n. Okay, this is the probability of getting 0. Okay, and this is probability of getting 1. 1 minus the probability of getting 0 is probability of getting 1 or more than 1. So, and this is equals to q by n because the probability of not getting 1 or getting 0 is q. So q was 4 by 3, you will replace it here and you've got the value of n is 6. So 4 by 3 to the power of 6, 1 minus 4 by 3. And this is 1 by 3. Oh, sorry. I was taking the value of this one. This is the value of q, 1 by 3 to the power of 6, 1 minus 1 upon 7 to 9 is approximately 1. So it is 0.99. Hmm. Next question, that is 7.9. This is also a good question. If x, the NP show that Ex and b by square is equals to PQ by n, coefficient n x n minus x upon n is equals to minus. Okay, let's see how it is solved. Since this is given, the Ex will be, that is the mean, is NP, the variance will be NPQ, and if you replace this, it will be E x by n equals to 1 by n, E of x, you'll divide by n on both the sides, and this will become and the variance will be v x by n 1 by n square into variance of x is equals to pq by n, and this will become p, and the n will be cancelled out, and this will be q by n because we are dividing with n square. First, first this part x by n minus p. So x by n we have already got it here minus p n square. So this becomes e. This was just p, so this will become x minus n minus p. So this was the value of p here. E x by n is equals to p. So we replaced this p with e x to the power n and its square. What is it equals to here? Oh, okay, okay. It equates to variance, so we have to prove this also. PQ by sorry, we have to equate it with PQ by n. So variance x by n, PQ by n. And the second part is how do we got it here? See, this was making this square makes this as n square, and the variance was n PQ by n. So this will become p square, and this will become n square by n square. How do you, let's see. Okay, you will take this 1 by n square and here 1 by n square outside, and the rest will become variance of x, that is npq, and it will eventually become pq by n. Next, position xn n minus x n is equals to x upon n minus e xn. Now this comes from this as this solved now. So okay. You will just see this same term is written here. Then you have to replace this by this and this by this only. So this was this, and replacing it by this, and then eventually this will become p. This will become if you open the bracket, this will become p. So it will be n 1 minus p, and this term here. If you now open these brackets, 1 minus x by n minus 1 plus p, so these ones cancel out, minus xn plus p, xn minus p. These minus should be opened, but okay. This will become xn square, and it will be, oh, okay, this will change the both of the, so it will be p minus xn, and here it will be xn minus p. It should be a minus b, a plus b, na? Both of the signs are inverted. So just open the xn square. Xn square. Wait. The minus should be here. No. Oh, the minus is here. So this minus comes here. This, just squaring it, and minus e xn minus b square is equals to now see this. If you open it, this resembles this part. X upon n minus p. X upon n minus p square. So if you open this, this will become m square, and this part will become including the p variance of x. So n square variance of x results into variance of x upon n minus of variance of x upon n, that is p q by 9. So minus of p q by n. These are recurrence. This is 7.10. What do we have after this? Binomial distribution, variance rings. Okay. Example number 7.10. Show that the earth moment are about origin of binomial distribution of degree is given as n. Okay, this is the given formula. We have to prove it. The principle of mathematical induction. You can see mu r is equals to p build upon delta p to the power of r q plus p to the power of n, and when you expand this, it will eventually the summation of n x from 0 to n nx dx q and q to the power of n minus x, and this will become, if you take delta so delta p, differentiate, it will become this n minus x, and this power will become x minus 1, and the x will come in front of the variable. So n, what is this then? It's the same thing as this. Q plus P, Q plus P. Okay, it is taking the P in the front. Okay, okay. And eventually it will be n minus x. Okay, this is new one. And you can see the solution. Hmm. Just wait a minute, guys. Let me see the syllabus. Okay, we will continue with recurrence relation, moment generating function, MGF, and then Poisson distribution, recurrence for Poisson, R for P. Okay. What are these questions related to? It was okay. Let's go to 7.24. This is the exercise. Example number 7.24. Okay. यहाँ से start करना है. Here 7.30. So 7.24. A car hired for has only two cars, which it fires out day by day. The number of demands for a car on each day is distributed as Poisson variate with the mean 115. Calculate the proportion of days on which neither car is used and some demand is refused. Okay, so more than the demand is for more than two cars. Okay. So this 1.5 is the Poisson ratio or Poisson variate. Oh, the mean is 1.5, sorry. So the proportion of days on which there are X demands is equals to P of X demand in a day, like two demands, one demand. So it is e to the power of the mean into mean to the power of X upon X factorial. So here it becomes E 1.5, 1.5 to the X and X factorial. Since the number of demands for a car on any day is a Poisson variate with mean 1.5. So it means किसी भी दिन जो डिमांड है वो एक Poisson वेरिएट है जिसका मीन ही है तो Poisson वेरिएट ये होता है x हो गया और जो x होगा वो 0 1 2 पता नहीं कहाँ तक तो पहला क्या है नाइदर का इज यूज तो ये 0 हो जाएगा जो हमारा डिमांड था x वो 0 हो जाएगा तो ये हो जाएगा e ये पूरा 0 तो 1 और ये पूरा 0 तो 1 सो सिर्फ e टू द पावर ऑफ -1.5 and that is 1 minus 1.5 plus 1.5 square by 2 factorial minus 1.5 cube by 3 factorial and so on and so on. So this will give us 0.2231. It's greater than 2. So 1 minus less than 2. So हमें less than 2 का निकाल लेंगे और फिर 1 में से माइनस कर देंगे. So less than 2 का क्या होगा ये वाला जो 0 आया था इसमें प्लस x 1 और 2 की वैल्यू के साथ तो यहाँ पे 1 डालोगे तो ये हो जाएगा 1 और इधर 1.5 सो 1 एक्स्ट्रा हो जाएगा यहाँ पे 1.5 मल्टीप्लाई हो जाएगा सो 1.5 आ गया ये पूरा वन टू, वन कॉमन आ जाएगा और यहाँ पे आ जाएगा टू है ना। सो टू, सो 1.5 का स्क्वायर बाय टू, 1.5 का स्क्वायर बाय टू, ये कॉमन आ गया। ये हमारे पास इसकी वैल्यू पता है, इसकी ये थी। तो वन माइनस दिस इंटू, इसको कैलकुलेट कर लेंगे, ये हो जाएगा 2.5 प्लस 2.25 बाय टू, तो 1.25 वन 2.25 1.125 प्लस 2.5, सो 1.125, 125 प्लस 2.5, 125, 50, 175, 175, तो 3.625, इसका 500 और इसका 125। सो ये आ जाएगा, इसको मल्टीप्लाई कर देंगे, 0.2 मतलब 1/5 अप्रोक्स, 35 7 के आसपास आएगा, तो 1 - 7 इज, अरे 0.2 के आसपास आ रहा है, सो ये कैसे 3.6। अच्छा कैलकुलेट करें, अच्छा कैलकुलेट करेंगे तो ये आ जाएगा क्या, लेट्स सी। 3.6 इंटू 625 इंटू 0.2231, 0.808, या तो यही आएगा। आगे देखते हैं, अगला एग्जाम्पल 7.25। कानपुर यूनिवर्सिटी, a manufacturer of cotton pin knows that 5% of his product is defective. अच्छा, if he sells cotton pins in boxes of 100, so उसमें से 5 हो गए खराब, and guarantees that not more than 10 pins will be defective. हाँ, okay. What is the approximate probability that a box will fail to meet the guarantee? हमें एन दिया हुआ, नंबर ऑफ बॉक्स हो गए, सॉरी बॉक्स में 100 पिन हो गए, प्रोबेबिलिटी हो गई 5%, और लैम्डा हो गया मीन नंबर ऑफ डिफेक्टिव पिन, 5 ही होगा। सो सिंस पी इज स्मॉल वी में यूज, अच्छा प्रोबेबिलिटी कम है इसके आने की। प्रोबेबिलिटी ऑफ एक्स डिफेक्टिव पिन इन अ बॉक्स इज 100। ये यूज करेंगे मीन, देखो ये फॉर्मूला था ई टू द पावर ऑफ माइनस मीन, तो यहाँ पे मीन क्या आ गया 5, तो ई टू द पावर ऑफ -5, 5 टू द पावर ऑफ एक्स और एक्स फैक्टोरियल। ये आ गया 5 टू द पावर ऑफ एक्स और एक्स फैक्टोरियल। एक्स क्या है हमें पता नहीं है, वो कह रहा है कि एटलीस्ट 10 पिंस ही खराब होंगी, उससे ज्यादा नहीं। तो 0 से 1 तक का समीशन कर देंगे, देखते हैं 0 1 2 लेस ग्रेटर देन 10, ओके 0 से 1 का नहीं, हाँ किया तो 10, 0 से 1 का 1 माइनस कर देंगे, क्योंकि हमें ये देखना है कि फेल टू मीट मतलब क्या, जो 10 से ज्यादा होगा, जो 10 से ज्यादा होगा तब फेल हो गया ना। तो 10 से ज्यादा होगा 1 - 10 से कम, 1 - 10 से कम होगा ई टू द पावर ऑफ एक्स, इसको कर लोगे सॉल्व, तो ये आ जाएगा कुछ इतना। तो सॉल्व भी नहीं किया यार, 1 - 5 टू द पावर ऑफ 0 1 2 3 4 5। ओके लेट्स सॉल्व इट। क्या है 5x/x फैक्टोरियल, समीशन फ्रॉम 0 to 10 हो जाएगा 5 टू द पावर ऑफ 0/1 प्लस 5 1/1 प्लस 5 to the 5 square/2, 5 cube/3 plus 5 4/4 plus 5 and 5/5, 5 to 6/6 plus 5 to 7/7 plus 5 to 8/8 plus 5 to 9/9 plus 5 to 10/10. So 1 plus 5 plus 25/2, 125/3, तो ये हो गया 25 ही, और 250/4, ये हो गया 125 आधा। ठीक है, 1250/2 इज 250। and this will become 1250 into 5 by 6, 1200 का 600, 50 का 25, 625 बाय 625 इंटू 5, 3000, 125, 3125, plus so on and so on. Let's give it to ChatGPT then. Solve 5 to the power of x divided by x factorial from range x to 0 to 10. It is coming at 146.38 and multiplying it by e to the power of minus 5. Multiply it by e to the power of minus 5. 0.9863, and 1 minus 0.9863 is 0.11 something. Okay. Oh, 7.6, 7.26. In the next class, we will study control system, I guess. Okay. 7.26. Six coins are tossed 64,000 times. Six coins. For what I face is what to take as n and what to take as x. So कभी कभी हो जाती है दिक्कत. Using the Poisson distribution, find the approximate probability of getting six heads r times. So six heads r times. So in uh, one set, that is six coins, getting six heads is 6 factorial. The whole chances is the 1 by 6 factorial. And I think, let's see. The probability of obtaining six heads in one throw of six coins is 1 by 2 to the power of 6. Yeah, that was I was saying. Half to the power of xp is half to the power of 6. Wait a minute. It is 0.015 x to 5. I was wrong here. Okay. So half or six times. अच्छा हाँ हाँ sorry 2 to the power of n होता है ना, x to the power of n. अब ये p आ गया. अब ये क्या कह रहा है कि उसका मीन क्या होगा? That head and tail are equally probable. Yes it is. So मीन हो जाएगा तुम्हारा np. मीन नहीं मतलब कितनी बार वो आ रहा है 6400 में कितनी बार आ रहा है. सो 6400, n हो गया हमारा 6400 और p हो गया हमारा half to the power of 6. So basically 2 to the power of 6. So 2 cube into 2 cube, and I can see that 64 is 8 square. So 8 into 8 and 2 cube cancels out. It's 100. So 64 times 6400 में 100 times आ सकता है 6 heads. Hence using this law, Poisson law, we require the required probability of getting 6 heads is. अब probability निकालेंगे. ठीक है कि 100 बार आ भी सकता है कि नहीं. Where x becomes r is e minus power lambda, and lambda to the power of r and r factorial, I think. Yes, the lambda is mean, so e to the power of minus 100 lambda, that is 100, power of r and r factorial. What was r? R is given r times. So 6 sets बार बार कितनी बार? तो वो तो तुम कैलकुलेट करो, वो तो क्वेश्चन वाले की जिम्मेदारी. 7.27 in a book of 520 pages. So approximately half of this book. 390 are typographical errors. But 390 typographical errors are there. Assuming Poisson law for the number of errors per page, find the probability that a random sample of 5 pages will contain no error. 390 errors. The average number of errors per page is lambda 390 by 520. So 0.75. हर 0.75 पेज में एक error है. Hence, using Poisson law, the probability of x errors per page is given by if x is x, e to the power of minus mean to the power of x factorial. Here is mean is 0.75, e to the power of 0.75, 0.75 to the power of x factorial. Ah, and it says 5 pages. Random find the probability of that a random sample of 5 pages. So we will do the test 5 times, na? So the 5 becomes the power of getting no errors. So no error x becomes 0. So you put 0 here. So 0.75 to the power of 0 is 1. And this denominator becomes 1. E to the power of minus 0.75 to the power of 5. Multiplying with e to the power of minus 3.75. Yes. Example 10.28. Suppose the number of telephone calls coming in a telephone exchange in 1 hour from 10 a.m. to 11 a.m. ठीक है. X1. Wait a minute. Suppose the number of okay, let's suppose it as n. X1 is a random variable with Poisson distribution with parameter 2. Okay, X1 parameter is given as 2. Similarly, the number of calls arriving 11 to 12. X2 has a Poisson this parameter of 6. X1 and X2 are independent. Yes, they are. What is the probability that more than 5 calls come in between 10 to 12? More than 5 calls. Okay, okay. X can be, we can say, the sum of x1 plus x2 by the additive property of Poisson. X is the variate. And those were the independent lambdas, independent means. So this is the variate. So it becomes lambda is equal to 2 plus 6, I think. Yes, it is 8. And the probability of x calls in between is given as p x is x, e to the power minus lambda, lambda to the power x, and x factorial, e to the power minus 8, 8x, and x factorial. And x is 0, 1, 2. And the question was greater than 5 now. So 1 minus less than 5. Let's see. 1 minus equals 1 less than 5 is 1 minus summation 0 to 5 e to the minus 8, 8x, x by x factorial, so e to the power of minus 8, 8 to the power of 0 by 0 factorial, 2 a to the power of 8, e to the power of minus 8, 8 to the power of 5, and 5 factorial. Okay, so it will become 1 minus 0.91912, that is 0.8088. Last question. Let's see. Example 7.29. A Poisson distribution has a double mode, f is equals to 1 and x is equals to 2. Okay. What is the probability of x will have one or the other of these two values? Oh, okay. Very simple. It's either the first value or the second value. We have proved the concentration in binomial, then the two modes will add to alpha. So this will become, oh sorry, lambda. I'm saying alpha. It's, how it's taking lambda is equals to 2. This is one value and this is second value. The 1 and 1, 2. And why it's writing minus 1 here? Okay. ठीक है लैम्डा आ गया 2 क्योंकि ये पहला रिजल्ट है दूसरा रिजल्ट है तो ये आ गया x इक्वल्स टू x e to the power minus alpha e minus 2 to the power x factorial 0 1 2 1 और 2 ही हो सकता है तो e to the power of minus 2 2 to the power of 1 upon 1 so twice of e minus 2 and here it becomes 4 but the same these are same so it will become this plus this plus this twice this four times of this is this okay. This was the last question. The next question is variate and then variates